Welcome to part 3 of our 4-part series on economic modeling. In this video, we will learn how to use the equilibrium condition to solve the model for the equilibrium values of the price and the quantity of beef. Recall from our previous slide that we have developed a market or a model for the market for beef in two forms. The first form is graphical. This should be familiar to you from your Principles of Microeconomics class. The second form is algebraic. Here I've expressed the model in algebraic form using the inverse supply and demand equations. An important point in economic modeling is establishing what is known as the equilibrium condition. The equilibrium condition is the point the model will move to, all else constant. It is a point of stability in the model. Recall from your Principles of Microeconomics that the equilibrium condition is the intersection of the supply and demand curves. From that, we arrive at one value for the price and one value for the quantity. This is known as the equilibrium condition. We can express that equilibrium condition in two forms. The first, we simply write that the price the buyers or the demanders pay for beef will be equal to the price that suppliers receive for the beef. That is what we call price equilibrium. The second form expresses the quantity demanded of beef will be equal to the quantity supplied of beef in equilibrium. Therefore, we have two ways of expressing the equilibrium condition. The first is in terms of the equality of prices. The second is in terms of the equality of quantity. We now turn our attention to solving the model for the equilibrium price and quantity. We can do this in two ways. We can use first we can use the reduced form equations and express the equilibrium condition as the equality of quantity. If we do that, we arrive at the following expression. What we have done is simply taken the two equations, set them equal to each other, and now we have one unknown, that is the price of beef. If we collect like terms and move the price of beef to the left-hand side, we arrive at the following expression. Dividing through by 18 gives us the following. The equilibrium price will be equal to $5, all else constant. Remember, in our simple model for the market of beef, the only other variable we have is the price of pork. We are holding that price fixed at a constant $3. If we now turn our attention to using the inverse equations, it simply states that the price of beef that demanders pay will equal to the price of beef suppliers receive. If we set the two inverse equations equal to each other, we arrive at the following expression. Again, collecting like terms, moving the quantity to the left-hand side, we arrive at the following expression. Dividing through by 0.4, we arrive at the equilibrium quantity. Therefore, if we hold the price of pork fixed at $3, we would expect the following to occur. The equilibrium price of beef will be $5, and the equilibrium quantity bought and sold will equal 70. Finally, we can complete the graphical presentation of our model by substituting in the equilibrium values of price and quantity. Keep in mind that the y-intercept of the demand curve is important. It is known as the reservation price of the consumer, and the y-intercept of the supply curve is known as the reservation price of the producer. We also keep in mind that the price of pork is held fixed. We remind ourselves of that by putting it in parentheses on the demand curve. Therefore, all else constant, we would expect the model to move toward an equilibrium price of $5 and an equilibrium quantity of 70. This now concludes our presentation on solving the supply and demand model using the equilibrium condition.